Hi everyone, welcome to the part 8 of Only Elevators tutorial series. And in part 7, we started working on our UI for our elevator instructions, elevator control instructions. And yeah, let's continue it. So we can do first, first we can do what we can do is if you can remember, if you play the game right now, you can see the Q&A elevator control instructions are showing every time, but we need to trigger this. When our character is only inside the elevator. So we have to show it when character is inside the elevator, and it should be hidden when the character is out. So that is the mechanic, that is the function that we are going to make today. So yeah, let's see how to do that. So you can see that there's this vertical box, and this is the box for the this is the vertical box. So this is the set of UI elements that we have for the elevator controls. And I can rename it as elevator controls. Yes, and now we can rename it as elevator controls. And if you go to the graph, now you can see that there are two variables. First one is image, and the second one is image 81. And if you go to the design, we can take a look. What are these images? And now you can see that these are the images, right? And these are two images, and those are the black or dark backgrounds behind this uh, key letter. And if you can see, uh, select the image and go to the details panel, and you can see next to this image, next to this element name, it has this tick on is variable, right? If we uncheck that and go for the next image and just uncheck it, compile, save, and go to the graph, and now you can't see it in here. That is because we can get any of the elements as a variable in here if it has this tick on is variable, right? So if we want to change something, or if we want to manipulate something, or if we want to add some script to some element of this hierarchy, we should select it and check on this is variable, right? So that is the basic thing we have to do, and we get that one in our variables list. So what we have to do is, so if you go to the design, and when selecting when this vertical box is selected, I can go to the properties, and now you can see there are various properties. uh, the one I am interested is, so there is this behavior, and then the transform. So where is this? Yeah, we can use, yeah, there's this part called rendering. And if you go to rendering sections, there's this render opacity. If you set this render opacity to 0, now you can see that this is not going to visible, because all the elements inside this vertical box is having this 0 opacity. 0 means it's not visible, right? So if you you can really control these two, uh, you can really use this variable to animate opacity for this kind of element. but also we can use this visibility as well. Now this visibility is kind of like a boolean, or it's like a switch. It just turn off its visibility like a sudden, but we can vary this render opacity value to increase or decrease it gradually, right? So these are the options that we are going to work with. Initially we are just going to get this visibility for our function, right? So what I'm going to do is go to the graph, and I just have to get this elevator control. Okay, so this is the reference. Now we have to drag a wire and search for visibility, and it has this set visibility node. All right, and you can see there are there are two set visibility nodes, but we should get this one under the widget, right? So get this visibility, and now you can see that there are few options. So first one is visible, the second one is collapsed, and the third one is hidden, fourth one is non-heat testable, and fifth one is non-heat testable. But this is self only, this is self and children, right? And if we summarize this, visible, non-heat testable, and non-heat testable, the second one, all this visible and non-testable too are in the visible category. So basically, those options are enabling the visibility for that widget element. So what's the difference? Visible is it's visible and it's heat testable, right? Heat testable means it can be interacted with mouse cursor, right? It can be interacted with mouse cursor, or it can be clicked. Basically, it can be clicked. But if you go to the non-heat testable, that means it is not clickable. It is visible but not clickable. That is the thing. And there are these two options for non-heat testable. And first one is self and children. If you set non-heat testable self and children, the element itself and all the children under that element will not be able to click, right? If there was a button that should be clickable, but if you set this non-heat testable to self and all children, that button will be not clickable after setting this to here, right? But if you test non-heat testable for self only, that means this specific element means we have renamed this vertical box as the elevator controls. So the vertical box will not be able to click, but if there are any other children that can be that is set to visible or heat testable, that will work, right? So that is the thing. So visible, non-heat testable, and not heat testable, these all three are in visibility range. If you go to here and click this elevator controls, and you can see that not heat testable is the default one, and also it is it has this self only one. It has this self only one. That means these can be clicked based on their visibility option. Now, if we take a look, click on this horizontal box. Now you can see that this is also not testable, not heat testable, self only. This is so also the same. And if we go to the image, you can now see that its visibility is visible. That means it's heat testable or can interact with the cursor, right? And if you go to the queue, it's also visible. If you go to the spacer, it is not. So all the text and image elements are clickable, but others are not. Others are just containers or functional elements, right? But since we are working on HUD or heads-up display, we don't need these to be visible, or we don't need these to be hit testable, right? Therefore, we can just use say self and children for this value, also for the default value. So this will be the default value. So I can this visible to I can change this visibility value to the non-hit testable self and children. So since we are in the HUD, this will not do any difference because we don't have our cursor um, when these are in the heads up display. So that is basically it. And what can we do? Yeah, now I should have a function called, yeah, I should have a function called hide elevator controls and show elevator controls. And if I go to custom event, I can call show elevator controls. All right, and I can plug it in here, and I can use this. And let's also have a one for hide elevator controls, and we have two options for that. So there are these two options, collapsed and hidden, and there's a small difference between these two. As its name, this just hides the UI or the elements of UI, right? That means it will not be visible, but it has or it occupies this space in the user widget. But if you collapsed it, it will be not visible, and also it will take up no space in the layout. Basically, it is kind of like it is deleted, right? It is not in the space. But why do we need that? To demonstrate that, I'll show you this thing. Um, yeah, let me do this thing. I'll wrap this element with a vertical box. Yes. Now we will have this vertical box, and I'll just have an text, and I'll put it onto here, and also I'll duplicate this one, and I'll keep the elevator controls in between these two text blocks, right? Now if you play, you can see that there are two text blocks, and if I select this and set this visibility to hidden, compile, save and play, now you can see that we can't see elevator controls UI elements, but it keeps its space between the text two text block items, right? It has this empty space in between, and then when you turn on the visibility, it it visibles in between. So that is the thing, right? Visible, and it shows hidden, it's gone, but space is there. But what if you select collapsed? That means we just don't have this space anymore, right? It basically collapses, right? So it's a simple thing. It's a simple thing to understand, and you can try this, and uh, it will be really easy to see, right? So it is that simple. So I'm going to undo those ones, right? Now, so what should we use? I'm going to select hidden. So I don't want any other UI elements on the heads up display coming down or changing their positions based on this elevator control height, right? So that is why I choose hidden. But in your case, you can decide which options to be chosen, right? And as I said, this should be the default value, and I set it as non-hit testable self and children, but I need to set it as hidden because it should not visible when the game starts. It should only visible when we go inside this elevator. So we have to turn it on. So I set this visibility to hidden and go to graph, and now you can see there are two custom events. So this custom event should be triggered by any other code, right? So that is the one. uh, that should be the thing to do. And how do I access this? How do I access this, or how do I trigger this? We can do this in two places. The main place that you can think of is elevator system or the elevator blueprint. Now if you go to the yeah, let's see, yeah, this is the blueprint class. Now where should this where should this show and hide nodes be called? Let's see. Yeah, we should call that in here. When our character goes into our trigger box, it should enable, and also it should show that um, that the instructions, right? So that is the thing. And what I can do also is I missed something here. If you can remember, we have to restrict that the other actor should be our player character. Therefore, we need to have this equal node, and we should check if this is our player character. If true, you should work. If not, it should not work. So that is the condition we have to put in here. And yeah, right. Now now we need blueprint communication, right? Now we need blueprint communication. So what is blueprint communication is, we do have this function, or we do have these two functions or custom events inside our WHUD, right? So it's a separate blueprint, it's a separate widget blueprint. It's basically a separate blueprint. And our BP elevator is another blueprint. So we need to call this HUD to access these things, right? We need to call this HUD to access these two events. To call to the HUD, what we can do is we can create, we can just basically create widget and select the HUD. Now, if you can remember, now this node has a reference to our WHUD. Now, if you compile and drag a wire in here and type show, it shows that show elevator controls. And if you search for hide, it shows that hide elevator controls. So we can use this here. So we just have to create this HUD and show elevator controls, right? And we can also do the hide elevator controls, right? Now if you play, nothing happens, right? If you play, nothing happens. Why is that? Why is this happening? So it should show, it should hide, but nothing is happening. So is this the right way of doing things, right? So we just have to uh, do some experiment. So what can we do? All right. Now the HUD is in our HUD is in our third person character, and this HUD is the one. This HUD is the one who is added to the viewport, right? So this is the one which is added to our viewport. Now we have this reference here. Now this is on the viewport. This should be the one. Uh, this should be the one to be called. This should be the one to be called. And if I drag a wire here and set this show elevator controls, plug it in here, and if you play, it just works, right? It just works. But the thing is here, it just not creates a reference, it creates another instance of the HUD and tells that okay, show elevator controls. But the thing is, this is the one who is added to the viewport. But let's say we can drag a wire, add to viewport, okay, and now if we play, it works, right? It basically works. And if I do the same here, right? If I do the same here, it should hide and add to the viewport. Now if you play, it doesn't go away. That is because every time this uh, code works, it creates a new widget. It creates a new instance and shows it and adds to the viewport. And when this executes, it does not refer to this one. It creates a new one, hides it, and adds to the viewport. Now you can see that This is a new widget, this is a new widget, this is a new widget. So those are three different widgets adding to the viewport. That means this logic is, this method is wrong. So this is the one should not to do, right? Therefore, we are going to delete that, and you know that this is the one we should control. Therefore, we should get a reference here. So this is the current HUD. So we have to control it. Therefore, we have to promote this to a variable. We have to promote this to a variable. And we can call this HUD. Right? We can call this HUD. Alright. And now this is promoted to a variable. That means this variable can be accessed and modified anytime. Right? Now if you get a wire here, if you call it, there is this show elevator controls and also the hide one asset. Now this is added to the viewport, and if you tell this to show, it just basically shows these elements, right? That is how this works. But to do that, now you can say that third person character has the access to the heads up display or WHUD widget, right? And it can show show or hide or control elevator control elements, right? Now you can see we are just not going to contact, or we are just not going to communicate with WHUD directly from BP elevator. We are not going to contact WHUD directly with this connection, right? But instead of that, BP elevator should call the third person character, and third person character should call the WHUD. So it is how the communication works. Our character is the centerpiece or the hub, right? Our character is the hub, and if you want to call someone, you just have to call to the third person character, and third person character calls to that person, right? This is the thing. Now what we should do is we should have our character reference here. We should be able to call to our third person character. To do that, we can't just get this, because this player character is any player character blueprint class. It should not be the BP third person character. This is the specific one. This is the specific player controller blueprint or the player character blueprint, but this is the generic one. This just outputs, this player character node outputs whatever the player character class we are using or the object we are using, right? It just not give us access to this third person character. Therefore, if you can remember, we are not going to use this one here. Instead of, we are going to use casting. We are just going to use casting. I know I said that casting is expensive, but we just have to use it, right? We just have to use casting in here because we have something, or we have this HUD reference to be called inside this elevator to work something out or work our UI thing. Alright, now we are going to delete that, and before adding casting, I'll show you that if you go to the mm, if you go to the asset here, if when you are in BP elevator, go to the asset and go to the size map, and now you can see that this is the size map for the BP elevator blueprint, right? Now you can see that these are the this concludes the disk size of this asset. So it takes 820 KB, but for memory size it has 1.5 MB. When this works, we have to have 1.5 megabytes for this asset. And now you can see that uh, what are the things that takes up space, right? Texture 2D, grid texture, grid material. So those are the things which takes up place, and script and the macros that are in this um, blueprint are really small. But if you go to the disk size, it's a little bit different. There's a little bit difference. It takes off macros here and blueprints here, and these are the other things in here, right? So this is how memory size and disk size work, and if you can see, this is 1.5 megabytes, right? 1.5 megabytes. But why we say this casting is expensive? Now we should get this other actor. So it basically gives a reference to the uh, overlapping other actor, and we ask that if you are the BP third person character, right? We just ask that. That is what casting does. Casting does is we check that if this object is our third person character, and if not, it executes this cast fail node. If this is success, it goes here, right? That is how it works. And you can also see that we have this control over this third person character. Now we can see things inside this third person character via this pin. That is why we are using this pin. Now you can see this is the third person character, BP third person character object. That is a specified one. That is exactly this. But if you get player character, it just gives a generic character object reference. But this is BP third person character object reference. That is why we can't ask what is the HUD variable here, right? This is the HUD variable here. It can't get you this HUD variable, but if you can if you go here and ask, it gets you the HUD variable inside here, right? So that is why we need to use casting, and now we have, and we can get our HUD. Okay, this is the HUD, and we are asking to show the elevator controls. Now it has, right? Now this is how this works, and we can do the same here. right? Connect here, connect here, connect here, and we just need to hide this elevator controls, right? Now this should work, right? Now you can see that this works perfectly fine. Now how this logic works, we have our created widget or created HUD reference here, and we have to set a reference here, and we added that HUD into the viewport, and we have to call it for its custom events or functions, right? And now inside BP elevator, we have to call third person BP, or we have to cast and specifically ask, give me the HUD, and from HUD we say show elevator controls, right? We call to third person character, and via third person character we call to HUD, and we ask them to we ask HUD to show hide elevator. So it is the basic concept, and what I was going to show was, now go to the asset size map, and now it has 111.3 megabytes just from the third person character cast, right? If you can remember, previously we had 1.5 megabytes. We only had 1.5 megabytes, but from this casting node, we now have a memory cost of 111.3 MB. That means about 90 megabytes has added to the memory size because of this casting node. That is why this is expensive, right? That is why this is expensive, right? Now you can see that you can do some experiments. You can just delete that here and compile and go to the size map, and you can see there is not a difference. So once you call, it has this uh, memory allocation to casting node, and it does not uh, calculate number of casting nodes inside. If you got one, it should be in memory. That is the thing, and it adds up about 90 megabytes only for this, only for this. Sorry, not 90, not 90. Sorry. Now, yeah, 1.5. So about 110, right? About 110, about 110 to 9. Memory has allocated for this. This is why casting is so expensive. Therefore, we can use interfaces. Therefore, we can use interfaces. So how do we use interfaces? How do we use interfaces? Now, if I say we can go to our UI and create a new blueprint interface. Okay, you can go to the blueprint interface, BPI, HUD. So this interface will be dedicated to HUD related data communication. Now I'm going to create a new function here, get HUD reference, right? this should get HUD reference, and we have to output HUD reference here, or we can just give this return value, and to this we can just get WHUD, right? So that is the reference that we need, and we just have to go to the third person character and go to the class settings, and there's this section called implemented interfaces. Now we have to find that interface BPI, and you can get this BPI HUD. So that is the interface, and when we add this interface here, it shows this get HUD reference function here in the interfaces section. If you go in here, I can just simply drag and drop this get HUD reference and plug it in here. Now if this called, if this HUD reference called, now if this HUD reference called, it can get this HUD, right? That is the thing, and we have to get in here, and we just can remove this, and call get HUD reference, and now we have this get HUD reference function can be called from anywhere, but there's this one thing called object reference, right? If you get it here, it gets you the HUD, and if you compile, it's correct. But what if I can get player character and connect it in here, compile, and it works as well. Now if I find show elevator controls and play, now that should work. Now you can see that we don't need this third person character anymore. We don't need this one. We can just delete that. We can just connect in here, and we can just find hide elevator controls here. It is perfectly working, and if you go to asset size map, now it has still this size. It has still this size, right? So blueprint interface has the same memory. Let's try again. No, it just have to be updated. Now it is back to the 1.5 megabytes. Now it is back to the 1.5 megabytes. Now you can see, if you have heard that blueprint interfaces can be used instead of casting, it is not the case, but we can use that like this and use instead of casting, right? It is not true every time, but depending on the situation, it can be true, right? It can be true. Now we have this interface used, and we got our HUD reference from our player controller, So our player can from our player character, so our player character is this one, and we have used this. So if you didn't get how blueprint interface works, I'll demonstrate it later, but for now you can uh, use it like this. So this is how a blueprint interface works, and instead of custom events in this graph, I can use um, yeah, I can use a function, and if I create a new function, I can call show elevator controls. Okay, right. I just have to copy this name, delete that, and rename it. Okay, I have to compile. Or now I have to cut this and paste it in here, right? Now we chose, and also we just don't need this to be a separate function as well. What I can do is I just I'm just going to delete this one and cut this one, go to here, paste this one, and I just have to get a condition. To get a condition, I have to get a branch, if true, if false, right? And I just can, yeah. Now this should work, and I'm going to connect this condition for the boolean to here. Now I ask the question show. Now when this show elevate, now when this show elevator function is being called, it asks that if you need to show this. If you need to show, if you check that, it will be true. Yes, show it. If not, it will hide this. Right? Now that's the thing. Now we just have to do this change. We have to delete this and find this new show elevator controls, and we have to show in here, but we just have to not to show in here. Now this just works perfectly fine, and when we are disabling our input, I am going to, right, I'm just going to resize this comment box a little bit and get some space in between here, right? And when disabling input, when once pressed Q, this is going to disable the input, and I am also going to hide this elevator controls as well until the animation works. After that, I'll do the same thing for the E as well, E key. After that, we have the set animation pause states. In here, we are going to show the elevator controls. Now, if you play and see that, now we have this elevator controls. Press Q, it doesn't show, and now it appears again. If you press Q, yes, now it works perfectly fine, and it aligns with the mechanic. Cool. Now now it settles down to it, and in next video we are going to give this a small we are going to give this a little fading animation, and let's see how to do that inside the widget blueprint and how to deal with it as well. And yeah, let's wrap it up then. And I think now you got the idea of casting and the difference between the using using the blueprint interfaces, and how casting is having this memory allocation size, and how blueprint interface is avoiding that. So it's basically a simple thing. So you can just ignore casting, or just minimize, not ignoring. There are some places that we have to use casting, no matter what. And yeah, I think I just have to do this one. Okay, we just need to filter it out, that if this is our player character, right? So I missed that one. Now that settles our code. Okay, right. And yep. Now yeah, settles it. Right. Okay. Right. Now let's meet in the next tutorial in part 9, and we have came a long way, and now we are getting a perfect elevator system. And this UI thing also can be called in your level blueprint as well. So yeah, I will talk about in the next video as well. So if we are about to implement this UI thing inside our elevator blueprint, let's see how to do that as well. Actually, it will not be a problem. So you just have to get the hard reference here, and call it here. That is because we can call this blueprint interface function anywhere as long as we have this get player character as the target, right? So that settles it. And yeah, bye guys, thank you. Let's meet at the ninth part.